Before we talked about simplifying radicals with negatives underneath the radical sign and said that there's no solution because you can't have a negative under the radical sign. That's true under the set of real numbers. For this first example, we're going to talk about the set of complex numbers, which includes imaginary numbers. So the imaginary number, the square root of -1, we use I to denote it. I squared then would equal -1. So for this problem, we're asked to simplify under the set of complex numbers. So what we're going to do is rewrite it as the square root of -1 times the square root of 60. The square root of -1 is I, and the square root of 60 we need to simplify, and that would be the square root of 4 times the square root of 15. We know that the square root of 4 is 2, so our answer would simply be 2i times the square root of 15. Our next example, we're asked to add two complex numbers in standard form. So standard form means that our final answer will be in the form a plus bi, a being the real part of the solution, the one that doesn't have the imaginary, and of course the second part, the bi being the imaginary part. So what we're going to do is remove parentheses first. So since there's nothing in front of the first group, we just drop the parentheses. If there's a plus sign in front of a group of parentheses, again, all that means to do is just drop the parentheses and nothing changes. Our next step is to combine like terms. So 3 minus 6 is -3, and -2i plus 5i is positive 3i. So it's in the standard form, the real part, the -3, followed by our imaginary part. Now multiplication, we use the same technique as if we had a variable x. We're going to use the FOIL method or the distributive property. So in order to multiply these, I'm going to start by distributing the 3 times the 5 and 4i. So 3 times 5 is 15. 3 times 4i is 12i. -3i times 5 is -15i. And -3i times positive 4i is -12i squared. So keep in mind what we said at the beginning, that I squared is the same thing as -1. So this would be 15 plus 12i minus 15i minus 12 times -1. So essentially what that I squared does is change the sign because it's multiplying that coefficient, in this case -12 by -1. So we have 15 plus 12i minus 15i plus 12. And then combining like terms, 15 plus 12 is 27, and 12i minus 15i is -3i. So the next two examples, we deal with a special type of multiplication. It's not the process, it's what we're multiplying. So if you look at both problems, the first one is 3 plus 2i times 3 minus 2i. So the terms are essentially the same, but one has a plus sign and the other has a minus sign. So look at the second example, exactly the same. They both have -2, they both have 5i, but they're separated, one with a minus and one with a plus. We call these conjugates of one another. And we can use a shortcut when we multiply conjugates. But if you don't remember the shortcut, and we're going to do this first, you can just use the FOIL or the distributive property method. So I take the 3 and distribute it times the 3 minus 2i. So 3 times 3 is 9. 3 times -2i is -6i. 2i times 3 is positive 6i. And 2i times negative 2 is negative 4i squared. Keep in mind, I squared is negative 1. So we're essentially multiplying negative 4 times negative 1, which just changes it to a positive. So we have 9 minus 6i plus 6i, now plus 4. Notice our middle term. Anytime we multiply a factor times its conjugate, we won't have a middle term. Notice the negative 6i and positive 6i would cancel out, and we would simply add 9 plus 4, which gives us 13. This will always happen. So knowing that, whenever we're multiplying a factor times its conjugate, we can use the shortcut of just multiplying the first two terms together. 3 times 3 is 9. Positive 2i times negative 2i is negative 4i squared. And remember, the I serves as really multiplying that negative 4 times negative 1. So it just changes the sign and it becomes 9 plus 4, which gives us the same answer. So in our second example, we're not going to use the FOIL method. We're just going to use the shortcut because we know they're conjugates of one another. So we just multiply negative 2 times negative 2, which is positive 4. Negative 5i times positive 5i is negative 25i squared. Remember, the I squared is negative 1, so essentially all that's going to do is change the sign. So that makes it 4 plus 25, which is 29. Makes the problem a lot easier. Next example is a division problem. When we're dividing and we have radicals as a part of our denominator, we go through a process called rationalizing. That means eliminating, essentially, the radical from the denominator. So you say, I don't see a radical. Well, remember that I equals the square root of negative 1. So you do have a radical in the denominator. So what I'm going to do is rewrite this using parentheses. So in order to rationalize, we multiply the denominator and numerator by the conjugate. So remember the conjugate, the terms are essentially the same. It's just they're separated by opposite signs. So since we have a plus, this would be a minus. So we'd multiply numerator and denominator by negative 4 minus 3i. In the numerator, since they're not conjugates, we have to use the FOIL method. So I multiply negative 5 times negative 4, negative 3i. Then I multiply 6i times both as well. So negative 5 times negative 4 is positive 20. Negative 5 times negative 3i is positive 15i. Positive 6i times negative 4 is negative 24i. And positive 6i times negative 3i is negative 18i squared. In the denominator, since they're conjugates of one another, we can use the shortcut. So we multiply negative 4 times negative 4, and that gives us 16. And positive 3i times negative 3i is negative 9i squared. So in the numerator, we have 20 plus 15i minus 24i. And remember that I squared is negative 1. So that essentially changes a negative 18 to a positive 18, because we're multiplying negative 18 times negative 1. In the denominator, we have 16 minus 9i squared. Again, we have an I squared, so that will change it from a negative 9 to a positive 9. Now combining like terms, we have 20 plus 18, which is 38. We have 15i minus 24i, which is negative 9i. And in the denominator, we have 16 plus 9, which is 25. We want to write it in standard form. So we're going to separate this into two fractions. 38 over 25 minus 9 over 25 I. You could have the I in the numerator, that's okay, but we usually just write it to the side. Next, we're going to get into solving quadratic equations. Quadratic means that our variable is raised to the second power. That would be the degree. So we're going to start by using factoring. So the first step in factoring is to remove the greatest common factor. So in this case, there is something that divides into 4u squared and 12u, and that would be 4u. So when I take out a 4u, that would leave me with u minus 3. So my last step is to set both factors equal to 0 and solve. So the first one I'm going to divide by 4, and 0 over anything is simply 0. So 0 is one of my answers. And for the second one, I'm going to add 3 to both sides. So that would give me u would equal 3. And so 3 would be my second answer. The next example, again, we're going to use the factoring technique and the AC method of factoring. Anytime we're solving a quadratic by factoring, we need to set the equation to 0. So we'd have 5v squared. I'm going to move the negative 26v from the right to the left by taking the opposite. So it changes the sign. And I still have the plus 5 equals 0. So here we use the AC method or the grouping method to factor. So I multiply the 5 times the 5, and that gives me 25. So now I write the factors of 25, either 1 times 25 or 5 times 5. I'm looking for the pair that when I add it equals the middle term of my expression. So I have 26 as the middle term, so 1 and 25 give me the 26. So I rewrite the middle term using those two factors. So again, nothing's changed. I just rewrote 26 as 1 plus 25. Order doesn't make a difference. You could put in 25 plus 1 and that would be okay. Now I group the first two and the second two and remove the greatest common factor. So I remove the v, and that gives me 5v plus 1. And in the second group, 5 divides into each one of these. So I take out a 5, and that leaves me 5v plus 1. The common factor is 5v plus 1. And the second factor would be those factors that we removed from each in the factoring by grouping step. Notice, and this will always be the case, after we take out the greatest common factor, those values inside parentheses will be identical. So my last step is to set each one of these factors equal to 0 and solve. So I'm going to move 1 on the other side and then divide by 5. So my two answers would be -1/5 and -5. The next concept is something called the square root property. So if you notice the next two examples, it's a little bit different than the standard form of a quadratic. In the first example, we have only x squared equaling 81. Notice there's no x term, that's x to the first power. Anytime we're dealing with a variable squared or a quantity squared, like y minus 2 squared, we can use the square root property. So the first thing we do is we isolate. So we want whatever's being squared to be by itself, and we want the constant to be on the other side. Now the 2, that exponent, tells us how many solutions we have. So the process is this. We need to eliminate the square, so what we do is the opposite operation, which is to take the square root. Now, how do we have 2 answers? When we use the square root property and we take the square root, it's the positive and negative solution. So on the left-hand side, the square root of x squared is simply x. 81 is a perfect square, so the square root of 81 is 9. So we have plus or minus 9 as our answer. So our 2 answers would be positive 9 and negative 9. So the next example, we're going to use the square root property, but we have to isolate the squared part first. So we need to move the negative 80 from the left-hand side to the right-hand side by taking its opposite. So it changes from a negative 80 to a positive 80. So now we need to get rid of the square. So we're going to take the square root of both sides, keeping in mind, again, we have 2 answers, the positive and the negative. So the square root of the quantity y minus 2 squared is simply y minus 2. And on the right-hand side, we have the square root of 80. Now we need to simplify the square root of 80. So the square root of 80 can be simplified to the square root of 16 times the square root of 5, because 16 is the highest perfect square factor of 80. Positive or negative, the square root of 16 is 4, so that gives us 4 square roots of 5, but we're solving for y, so we need to add 2 to both sides. Notice I'm putting it in front of the plus or minus sign. So the answers would be y equals positive 2 plus or minus 4 square roots of 5. Remember, 2 answers, 2 plus 4 square roots of 5 or 2 minus 4 square roots of 5. The next concept is a concept called completing the square. So before we get into actually solving a quadratic using completing the square, we need to look at the steps used. The first thing that we need to do is create what's called a perfect squared trinomial. So a perfect squared trinomial is a trinomial that factors to one factor times itself, or to that factor being squared, which means the factor times itself. The second step will be using the square root property, with which we just did 2 examples prior to this particular problem. So how do we create a perfect squared trinomial? So here we're given y squared minus 16y plus some number. Well, what number do we add to that so that when we factor it, it factors to a quantity square? The step is quite easy. First of all, the leading coefficient of the x squared, or y squared in this case, has to be 1, in which it is. Then we take half the middle term. So half of negative 16 is negative 8. And we simply take negative 8 and multiply it times itself, or square it. So negative 8 squared, or negative 8 times negative 8, gives us 64. So when we add 64 to y squared minus 16y, we've created a perfect squared trinomial. So now let's take that and the square root property and solve a quadratic equation by this process called completing the square. So I'm going to rewrite the problem: x squared plus 8x plus 14 equals 0. So the first thing we do is we isolate the x squared and the 8x by moving the 14 to the other side of the equal sign. And remember, since we're moving positive 14 from the left to the right, it becomes negative. Now I need to create a perfect square trinomial with the x squared plus 8x. To review, we take half of 8, which is 4, and we multiply it times itself, or we square 4. When we square 4, that gives us 16. So in order to create a perfect square trinomial, we need to add 16 to x squared plus 8x. We can't just arbitrarily put a number there. We have to balance the equation. So since we added 16 to the left-hand side, we have to put it on the right-hand side as well. So now we factor, and we know on the right-hand side, negative 14 plus 16 is 2. So how do we factor? We know that x will be the first term. Now this middle part, or the second part, how do we get that? All we do is we take half the middle term. So half of positive 8 is positive 4. So that means x plus 4 times x plus 4 would give us x squared plus 8x plus 16. Let's go back to the previous problem real quick. We had y squared minus 16y plus 64. How would that factor? We know that that would be y, and then we take half of negative 16, and that would be negative 8. So y minus 8 squared, or y minus 8 times itself, would give us y squared minus 16y plus 64. So to fill in this form, it'd be the first one. Whatever the sign is of our middle term, since it's plus, would be the sign when we factor. So half of positive 8 was positive 4. And again, we would have 2 on the right-hand side when we combined negative 14 plus 16. How do we finish it? We're going to use the square root property. So we take the square root of both sides, keeping in mind we have 2 answers, the positive and the negative. So the square root of the left-hand side is x plus 4 equals positive or negative square root of 2. And then we're going to move 4 on the other side. And remember, we're putting it in front of the plus or minus sign. So our answers to this would be negative 4 plus or minus the square root of 2. Our last 2 examples deal with solving quadratic equations using the quadratic formula. So the quadratic formula is x equals the opposite of b plus or minus, because we have 2 solutions because it's quadratic, the square root of b squared minus 4ac all over 2a. Well, where do the a, b, and c come from? Well, when we write the equation in its standard form, the a is the coefficient of the x squared, the b is the coefficient of the x, or a middle term, and the c is our constant. So when we look at the problem we're given, 2x squared minus 5x minus 4, it's in standard form because you want to make sure you set it equal to 0. Now we identify the a, which is 2, the b, which is negative 5, and the c in this case, which is negative 4. So the value in front of the x squared is a, the value in front of the x is b, and the constant is c. Now we plug those into our quadratic formula. So the first thing we do is we find the opposite of b. Since b is negative 5, the opposite would be 5 plus or minus the square root of b squared. So negative 5 squared is 25 minus 4, because that's always part of the equation, or formula in this case, times a, which is 2, times c, which is negative 4, all over 2a, which is 2 times 2. So we have 5 plus or minus the square root of 25. Now we take negative 4 times 2, which is negative 8, times negative 4 is positive 32 over 2 times 2, which is 4. So we have 5 plus or minus the square root of 57 over 4. If we could simplify the square root of 57, we would. Since it doesn't simplify, those would be our two answers: 5 plus the square root of 57 over 4 and 5 minus the square root of 57 over 4. Our last example, we're going to use the quadratic formula to solve, but our answer may be within the set of complex numbers. So we may be incorporating I as a part of our final answer. So again, the first thing you want to do is make sure it's set equal to 0, which it is. Identify your A. Since we have 1x squared, A is 1. Middle term, B equals -5. And C in this case equals 7. So we're going to plug it into the formula. So the opposite of B, so the opposite of -5 is +5, plus or minus square root of B squared. So -5 times -5 is 25. Remember, it's always -4 times A, which is 1, times C, which is 7, all over 2 times A, or 2 times 1 in this case. So we have 5 plus or minus the square root of 25. So -4 times 1 is -4, times 7 is -28, all over 2. So this would be 5 plus or minus the square root of -3, because 25 minus 28 is -3 over 2. We don't want to leave our answer in this form because we have a negative underneath the radical sign. So that'd be 5 plus or minus the square root of -1 times the square root of 3 over 2. So 5 plus or minus I square roots of 3 over 2 would be your final answer.